Hello, everyone. I'm Risha, and I work on the Linkerd service mesh, and I'm going to introduce you to Zhen, who will be talking to us about how to manage CRDs and operators in practice. He is a software engineer at Alibaba, and he works on cluster management. So let's hear what he has to say.
Thank you. Hello, guys. So how many operator talks have you heard in these days? One? Do we have another competitor? OK, I personally have three operator talks, so I believe I'm the winner. Then, in this talk, I will talk about the general ways to manage CRD, customer resource definition, and the operators. So I will not focus on one particular operators. So who am I? I'm Zhen Zhang from Alibaba Cloud. For your record, Alibaba Cloud is also maybe the largest cloud provider in the world. And you may contact me through Slack or just send me an email. I begin this talk because in Alibaba, we undergo a journey to cloud native. Actually, Alibaba began its journey to cloud native in very early days. In 2011, we have already moved all our virtual machine application from virtual machine to Linux containers. And in 2015, we introduced Docker image and Docker files. And we also built our first container orchestration platform using Docker Swarm. But in 2018, it is very clear to us that Kubernetes, the standard declarative API of Kubernetes is much superior, and it has very great customizability. So we began to migrate our container platform from Docker Swarm to Kubernetes. And during the process, we are building our many enhancements and are also helping our developers to build their operators. So currently, we have around more than 100 customized resource definition. Those are developed by more than 10 teams across the country. Actually, most of them are not very good at Kubernetes. And out of these customized resources, 1/3 of them is built in-house. So in other words, there is 70% of the customer resource is in just using our open source softwares. So why we are building customized resources and operators? First of all, during our journey process to migrate to Kubernetes, we find that we need to give some enhancement to Kubernetes in non-intrusive ways. So we kind of build our own stateful set replacement so that we can update the port in place instead of recreate the port every time. We also built customized controllers so that we can integrate our Kubernetes port with our own infrastructures, such as config management database. On the other hand, we also have many stateful applications. Most of them come from middleware team, for example, message queues. So we are helping them to build their own operators. And also we have many teams, they just use some open source software, such as Kubeflow. They will install those software in our clusters. So most of these software now ships with some kind of customized resource, and there are some operators within. So when we manage some stuff, we have to know who the user and our partners. So the first user, of course, is just ourselves, and I believe most of the people here come to this category, so I name it Captain. And it's actually just a beautiful name for the administrator of their clusters. These people have great knowledge about the Kubernetes and also the Go languages. But come with the great power, because you have the administrator privilege, come with the power is your responsibility. You have to make your clusters in order. You have to make them running all the time. So sometimes we get a kind of obsessive compulsive disorders. So nowadays we have to also be psychologists in Kubernetes instead of just engineer to get the work done. So another kind of person, we name it cowboy. It's just a name for other teams. They may be some expert for some platform, and they have limited, maybe a lot, also great knowledge about Kubernetes, but still very limited compared to us. But they do have some great knowledge about some domain, but they always mess something up in your clusters and always outsmart you in surprising ways. The third kind of person, I name it the businessman, but actually they are also engineers. But they are experts in some particular applications. They have in-depth knowledge about the application and their business logics, but they basically have no or little knowledge about the Kubernetes or Go language itself. They are very curious about Kubernetes, but they cannot invest many time in learning them. Of course, they also come with a lot of legacy in those non-cloud native days. Also, some of those engineers are just forced to write some operators because we are driving them. So as a captain of our clusters, how we organize those three kinds of persons so that we can build better and good operators. So here the first, and ironically the first problem is how to make them right operators. Actually, right operators is not very easy. So the solution, I believe, is to make sure that whether or not you just actually need to write operators. I will talk about that later, but in many times you just need a Helm chart that will suffice many cases. So if you do have some business application logic, you need to write them in in operators. So you have to learn how to write operators. For starters, they have to overcome many difficulties. They have to overcome the concept overload of Kubernetes, and they also have to break language barriers. At least that you can build some operators, but if you fail to overcome the language barrier, many our developers come from Java world, so they just get cold feet, and maybe they're just using Java client library and they call Kubernetes in an external way, so they never get a chance to write native Kubernetes operators. But in the end, if they do come across the language barrier and the Kubernetes concept, they also have to learn the controller pattern. I believe there is no shortcut here. But here we do think that if you can use kubecontrol or operator toolkits, it can greatly speed up the learning process. So we come up with some tips to speed up the learning process. I will just skip to the last two tips. Is we have to give them easy access to good sample operators. For example, you have to set up some kind of your own version of awesome operators or your own version of operator hubs so that they can just follow the good examples. Another is they have to make some standards and offer some best practice because those developers they can write controllers in their own understandings. So here is what is the standards. Basically, for the problem we have to solve in a standard is to come up with some naming conventions. The developer, they can, when they start to write operator or customize resources, they tend to make mistakes in naming those resources. For example, they can name exactly the same as the built-in Kubernetes resources. That may give many confusion when used them. They may also give the resources a very unclear group names, which is also very ambiguous. They also don't have access to some Kubernetes recommended labels. They just will come up with some their own names. So we just make some kind of CRD standards. First of all, they gave them some naming conventions. In Alibaba, we made some simple rules. For example, you have to give a clear name, such as a diamond. It's unambiguous names. And you can also have your API groups, which may contain your business units in your companies. We also define some common resource category. Category is recently introduced a field in customized resource definition. For example, we define apps for workload customized resources. For those apps customized resources, we enforce that they must provide scale sub-resources and also a rollout control definition. I will cover that later. And we also make some common labels across the company. When the developer have followed our rules to write, the operators, they often make some common mistakes. One of the mistakes here in the first item, I believe, is ironically many of our operators, developers in open source projects also made that mistake, is that they tend to use operators as a replacement for package management. They simply wrap the underneath resources in the operator, and that doesn't include any operational logics in the operation. So we believe that it's an overkill and it doesn't waste our time for our developers. So we recommend them, if you don't have any specific application operational logics, just use Helm or other package management solution. Another common mistake they make is that they tend to reinvent the wheel because they don't. Those developers tend to they don't have broad access to all Kubernetes resources. For example, they don't have a great understanding about stateful set or config map. They tend to add many fields in the customized resource. So we recommend them to reuse as many as possible those resources built in Kubernetes. Also, they also try to retry during the controller reconciliation. They always try to retry if encounter any errors, or they tend to always wait for some time-consuming operation. So we would always recommend them to just for all these cases, just append the work item into work queues. And last mistakes, just they tend to use old imperative way of design the controllers, design the software. So they have to converge to the new declarative design. Another problem is that when they have finished their operators, they want to get their operator and the customer resource installed in the clusters. But unfortunately, we as administrator of the clusters, we are the only person who have administrator privilege. So they have to come to us for help. Unfortunately, in previous days, we do some the whole request and process is done manually. In fact, in here is an example that we use a chat application as a channel to serve those CRD or access requests. I will not go through the detail of these conversations, but it's clear that it's to use free text or human language to describe the resource RBAC, to describe the resource definition. Resource definition is very inefficient and time-consuming. And then when we try to make the RBAC manifest manually, you tend to it is very, very prone to errors, and always comes with bad user experience. And what's more is that if you have more clusters, or the user want to just edit or modify some of the RBAC's rules, the whole process must do it all over again. So it's just not sustainable and not repeatable. So we may ask, why not just using Helm? You can use a CRD install or just put customer resource definition manifest in your charts. We think that if you're using Helm, because Helm is just a giant pseudo servers, you just give up all your responsibility to manage the clusters. So we don't take this approach. So the solutions is that we introduce another repository. It's for resource metadata for our partners. So in this repository, you host meta configurations such as customer resource definition, RBAC rules, services count, and maybe some webhook related configurations. It also serves as an awesome operator list for internally. So you have a list of the CRD corresponding to the operators. You also have a developer name so that other developer can contact them and communicate. And they also have a link to the operator repository so that whenever other developer want to reference or call those API, they can access to the type definition and the client set. It's also a place where we make the review process. So here comes the review, the CICD based access review process. So when a developer wants to commit to make change to some customized resource definition or gain access to a new cluster, they just fork they forked the resource metadata repository and made some change and sent a merge request to our cluster administrator. Cluster administrator will try to review whether those changes are proper, or whether they conform to our standards. So once they have accept those merge requests, the Jenkins or the other continuous integration systems can take over and do the syntax check. For example, you can do a dry run against the Kubernetes API server. You can also write a script to make sure that all that your customized resource definition or service account or labels just compliant to our CRD standards. And the Jenkins also makes the last step that is to apply those resources one by one to one of those clusters. So here there are some missing pieces here, is that so when Jenkins do the test against those resources, there's some common problem we found that, for example, when you want to gain access to clusters, you have to provide a request to a kubeconfig or just provide a name for the service account you want to get. But if it doesn't provide the necessary resources, it's definitely not going to work. Also, you can test here is that you can check whether or not your provided customer resource name has conflicts with other built-in Kubernetes names. Also, you can check whether those names have already been used by other teams, so that it's a very good chance to let them just rename those resources. For the customer administrators, the common review problem is that many of the developers just want to get access permissions. For example, they just basically want all those permissions to pour, to node, every stuff, so that we have to question them let them make the reasoning. So also we have to make sure that the developer doesn't try to write a webhook for some internal type like ports or nodes, because if you write a webhook for some such core types, core resources, we have to make sure that they have made effort to ensure the reliability of the webhook servers. So here is the last pieces to apply the resources into the Kubernetes. You have to give the ability to request for a kubeconfig. So here we make a little tool that we define our own customized resource called kubeconfig request. You can fill in your username for the kubeconfig and the corresponding groups, and just fill in an email address or some chat account, so that we can send those kubeconfig files directly to you. Another little utility is that we made another annotation in service count, so that whenever a webhook server startup, you can mount extra serving credential from the service account. So when our developer has set up the clusters correctly, they also want that their operators can get rollout and integrated well with other CICD pipelines. I mean here the resource here is that for operators, they usually is actually one type of workload. So if you want to deploy a workload online, you have to go through all the pipeline. For example, when a developer for MetaQ operators, they change their MetaQ implementation, they just commit their code in the code repository and may let the Jenkins take over and build the code, build the image, and push to the Docker registry. Here comes the first problem, is that Jenkins don't have no idea that where to put those generated Docker image into, because in customized resources, they have no clear standards where to put those images. So in typical GitOps setups, there were another role here, the operator, the human operator. Human operator will commit those Kubernetes resource configuration into the config repository, and the continuous delivery system will do some template rendering or do some customizing, and in the end, they will apply those resources into Kubernetes API server. But if you want a very reliable rollout, you have to come up with some controls. For example, when something goes wrong, you have to have the ability to pause the rollout process. You have to also have the ability to know the progress, how much to progress of the rollout, whether he has finished, whether he has just get stuck in the middle. So to our first problems is that we also come up with some local standards, is that we ensure that each operator must packed with Helm chart, and they have some common Helm values. And that is, for example, they have some values called images. And in the right side, in the customized resource YAMLs template, you can just render those values into the correct place in your customized resource manifest. Another problem is that how to control the customized resources. Currently, there is no available solution in existing open source world. So we come up with some this kind of also our own customized resource called rollout control. It contains some common knobs to control the rollout. For example, you can specify the name of your customized resources, the kind of your customized resources, and a pause field to control whether you can pause or resume the rollout. You also can control your rollout partitions, just like in stateful set. You can also control how much unavailable ports is tolerated during the rollout, such as like in deployment. In the status, you can also build common information, such as how many replicas are there, how many of those replicas got updated. The problem is that not every CRD for customized resources contain all those knobs. So we define another customized resource called the rollout control definition. It just basically defines that for each common rollout control knobs, where the exact JSON field of the JSON path of of that field in your operators CRDs, customized resources. And if you do not have such capability, so you just can leave it blank so that the continuous delivery system can know that it cannot support ports, it cannot support partition abilities. Arguably, that in most of our operators we found in GitHub, many of them just don't provide any rollout ability. So so we have to make this such kind of rollout control rules internally. So let's wrap it up and conclude our lessons. And so we make some standards for CRD and operators. We also enforce those operators with our CICD pipeline reviewing process. Lastly, we make our CICD pipeline works friendly with those operators. So that's all, thanks.